Hey everyone, welcome to Exponential and Logarithmic Models. This is Mr. Bennett, and this is going to be our first example. We're going to do part one of two of this. And so what we're really going to be looking at is being able to apply exponential and growth and decay models to a bunch of different situations. And so let's look at our first example on world populations. Okay, so in our first example, the world population is the total number of humans on Earth at a given time. In 2000, the world population was 6.1 billion, and in 2005, the world population was 6.5 billion. Okay, find the relative growth rate and determine what year the population will reach 9 billion. Okay, so what we want to first think about is writing the exponential growth model. Okay, so that's n of t, and you can use different variables. I chose n of t, and that's going to be n sub 0 times e to the rt. Okay, and we know that n sub 0 is going to be our initial population. There's a couple other things that we need to discuss though, and that is that we're going to let t, okay, being 0 correspond to 2000. That's the initial year. Okay, so that means t equals 5 in the year 2005. And so we've got to use a couple things here. We know that in 2005 the population is going to be 6.5 billion, and that's going to be equal to the initial population, which was 6.1, okay, e times the rate to t, which is going to be 5 times r, right? T would be 5 in this case at 6.5 billion. Okay, we didn't want to use 0 here for t because anything to the 0 power is just 1. Okay, so now what we have to do is solve this for the growth rate, which is what they're talking about in the step above. Okay, so now I'm going to divide each side by 6.1, so I have 6.5 divided by 6.1 is going to equal e to the 5r. Okay, now what we can do is we can get rid of this e by taking the natural log of both sides. So we're going to have the natural log of 6.5 over 6.1. I'm actually going to leave that, equals the natural log times e to the 5r. Okay, the right side is what's key. We're going to simplify that just to being 5r using our properties of exponents, and we're still going to leave this as the natural log of 6.5 over 6.1. To solve for r, we divide each side. Okay, we're going to divide each side by 5. Okay, so when we take the natural log of 6.5 over 6.1 divided by 5, let's see what we get. We're going to get our r value. Okay, so our r value here, if we use our graphing calculator, okay, we're going to take the natural log of 6.5 divided by 6.1, close that off, and divide it by 5. Okay, and so we get 0.0127. Okay, that growth rate, if we move the decimal 1-2 places to the right, is going to be approximately 1.3% is going to be our growth rate. Okay, so stay tuned for the second part of this video.